Firebase and Google Cloud Platform. So I will, first of all, cop to not being a mobile developer in any way, shape, or form, except for things really cool. And I've rooted several Android phones in my day, installed custom ROMs and that sort of thing. But Firebase is, I think, as close as I get to mobile, but as close as some of you may have ever gotten to Google Cloud. So I think it's an interesting topic to start off discussing, what's new in Google Cloud, kind of what I've seen I've been at Google 4 months now, so I'm relatively new, but it's been real rapid growth and just a lot of new technologies coming out. And basically, the thing about Google Cloud is, if you think about it, we started with App Engine, right? 2008, we thought, well, here's the deal. We've had a lot of thought of this at Google about how should we build an app, how should we run it, how should we deploy, how do we scale, how do we maintain? And we thought we'd solve the problem. And we said App Engine is the answer, and everyone should just go and run App Engine. And people would look at us and say, what do you want us to do with this exactly? Like, it was very different from what people were traditionally used to when they tried to run an app backend. And so we evolved. This is a larger ecosystem now. But you have to remember that it started with PaaS. It started with platform as a service, and it's grown into a lot of other services. So real briefly, who here is familiar with Google Cloud, knows that it exists, versus has used it, versus is deployed an app on it? Show of hands, anyone? A couple people? OK, maybe half of you. All right. So we're always growing our offerings. We're growing our team. I feel very fortunate to have joined Google at the very end of last year. And we're really focused on the enterprise. And so me being traditionally from an enterprise computing background, I was really thrilled to be able to join the team and to contribute some of my knowledge and to be exposed to a lot of cool technologies. So we can go through some of them in more detail, but I'm going to focus on a couple things tonight that I thought are pretty cool. So in particular, we're going to talk about the evolution of Google Cloud started again. Caveman days. We were running servers, maybe VMs, we're managing them ourselves. It sucked. We didn't like it. Started with App Engine, kind of for hipsters, and not a lot of people got it yet, but we kept going. BigQuery, cloud storage, cloud data store, data flow. Real briefly, ways to analyze and store your data, right? Firebase came along midway through 2014. It was an acquisition. It had a real-time database for mobile that we thought was pretty cool. And we built on that. So other solutions came along. Cloud Functions is something we're going to use tonight that I think is pretty cool and goes along with these. So basically, Cloud Functions is a way to go even beyond PaaS and do what you could call serverless computing, right? It's a Lambda in the cloud, basically. And new things keep coming up, like Cloud Spanner, which was announced at Next 2017, which is basically mind-blowing. We can talk about that, too, if you have any questions about in the Q&A. Basically, it's a huge database that is everywhere at once, but it's transactional. It's magic. Atomic clocks are involved, so it's pretty cool. But App Engine, right? It was for hipsters. So what do? For mere mortals. We want to make a thing, right? So I have my device, and I have an API, I guess, and I'm going to run it on a VM. OK, cool. That's great. So we got a hello world out there. But I need to scale it, right? So I need to put some backends on it, do some analysis, post some text, post some images, user content, make it bigger, much bigger. Maybe I need to load balance it. Maybe I have a fleet of VMs now, all doing their own backend analysis or data processing tasks. And how do I manage this thing, right? Well, it starts out small, gets bigger, gets bigger. You see the point, right? This can quickly become unmanageable if you're doing this on your own. And this is not work. This is toil, right? This is a task you have to do over and over and over again just to keep everything running. It sucks. So we've been here before, right? This is where PaaS, this is where mobile app backends on App Engine would be a really useful thing, right? But we already have a product that does that. So where do we plug these things together? And how do we make it even easier, right? App Engine is an option. I'm not here to talk about all of App Engine today, but we'll come back to it. Cloud Functions, on the other hand, is just code, right? It's just something up there that you can send your request to. You have an API you can hit, you get a response back. You can do really magical things with just that and not have to manage any infrastructure. So even from a mobile app, you have a lot of flexibility to really expand the capabilities of your app without having to invest in all that infrastructure and all of that management overhead. So what I'm getting at is there's a continuum of compute, right? So on the left, on the red's bad. Maybe if you are trying to minimize your effort, a lot of mobile development is lean, right? And you want to kind of keep it that way. So you have raw compute power. You have very granular control. You can care for and feed a VM that you've lovingly handcrafted. You can image that. You can scale it out. That's awesome. We have a lot of customers who do that. So that is a lot of configurability. It's also a lot of DevOps. It's more work, right? Container engine based on Kubernetes, right? So think of the data center as one big computer, and think of declarative management as sort of the fundamental task you're doing rather than going in and logging into machines and managing them individually there. So Kubernetes is a container orchestration engine that Google open sourced and released, and Container Engine is the managed version of that. App Engine we heard about. It's PaaS for hipsters, right? It's got a runtime that you can utilize to do a lot of different things, and you can focus on the app logic. If you go all the way to the end of that spectrum, you get to Cloud Functions, and it's just reactive programming at that point. So you're from DevOps to NoOps, and you give up the ability or the duty to go and configure VMs by hand, which might be a good thing, right? So Compute Engine, why do you want it? You get a lot of flexibility. You get exactly what you ask for. There's a lot more to deal with. So you start thinking at the low level. Container Engine, you want more performance and repeatability. You want to think about it differently. And so you can start to design things like on a whiteboard, basically, right? What are the programs? How are they connected? Not so much about where are my VMs. App Engine, we've heard this before. It's portable. In fact, you can use containers on App Engine now. It's a kind of cool thing. It's called the Flex Edition of App Engine. So you sort of have options here, right? And now you only have to think about code, HTTP requests, be versions of your app, create microservices. Everything's great, right? Cloud Functions. You don't even have to think about servers. No big deal. Your experience is as simple as it can be, hopefully. Still have to debug, unfortunately. But now all you have to think about is events and function definitions. And those are the only two things that I had to use to create what we're going to show off. Where do you run your code? It depends. TLDR. OK, got it? Good. So Cloud Platform 101 for creating a backend. You pick a place that you want to run based upon the level of complexity you are willing to endure versus the level of control that you want to get out of it, right? So what's this have to do with Firebase? Phillip, they're mobile developers, and you put Firebase in the title. So what have you been talking about Cloud Platform all this time? And who cares, right? OK, fair, fair. So two big things that I used to create what should be a pretty cool demo in a little bit here. Cloud storage for Firebase. So this is something that was pre-existing last year. You can write to a Google Cloud Storage bucket. It's just a block store, basically, if you're familiar with that sort of thing. If you've done AWS, it's like S3. I think ours is better, but I'm biased. Cloud Functions, again, Lambdas in the cloud. Just go call some code and get it done. And you can connect this to Firebase. It's pretty cool. So don't want to build an app with servers, right? You want to build a mobile app, but not with servers. Firebase apps are meant to be serverless. That's pretty cool, right? You can just sort of point things at your platform as a service, backend as a service, and get access to all kinds of cool things. But if you start with an architecture like this, it's supposed to make it really easy to scale and really easy to manage, but you want to add additional things. OK, so we have a big platform. We have a lot of things that you can get out of Firebase. These are all basically managed for you. So there's three big tiers of it. The development, the sort of promotion and sort of monetization, if you will, and growing your app and growing your user base. So as App Engine is to cloud, Firebase is to mobile development. But how do we plug them together, right? What do you put in there? Put in some servers to connect the two? Probably not. We don't like that, right? We've already been there. So Cloud Functions are the way to do it. If you're a hipster, it's pretty cool. So we're going to do some image processing today. So let's build a messaging app, shall we? Next, they called it Hipster Chat. I didn't have that code, but we tried Friendly Chat because it's cool to be hipster, but you should still be friendly to people. So what we've got here is an app that hopefully you can see this URL here, but you are welcome to put that in to your mobile phones, as I will do now. The idea is we got a couple pieces going on here. First of all, we've got a simple UI. We built this up out of a code lab. We've got an SSO component here to allow you to log in. You authenticate with your Google credentials. We can put in a message here, say hello world. It's going to show up. We have a database backing these that show when I post a new message, and we've got a notification component. Pro tip, if you allow Chrome notifications from this app, it will spam you for the rest of this talk, just fair warning. But there you go. And then we also have, of course, a no chat app is complete without memes, so we have an image upload feature. Now, this is where I should digress and talk about the care and feeding of your audiences, because just like servers require maintenance and code requires debugging, your audiences sometimes may be offended by the content in your code labs, right? So we said, we're just going to let anyone post anything we want up to this chat app. And what if they post something we don't like? And how do we moderate it, right? And what if it's at scale? And we can't do that on a manual basis. We're not going to be able to scale the content moderation. We're not going to be able to hold people back from posting things. So while going through these code labs and setting up, and I'll share the links of these at the end, one thing I noticed was that they had a section for content moderation. And they said, well, here's the code lab, and why don't you put in a moderation piece, and then you can see if it works. And I thought, that doesn't sound like the best thing to do for a live demonstration that's being recorded. So please don't put anything terrible in here. The fact that you have to log in will hopefully dissuade you from doing that, because your name will be on it. But if you do, it will blur things out. So I will go through the steps in a second here. But the gist of it is, hello, Eric Berner. Welcome. Hola, Eric. So we can post an image of our choosing. For example, a picture of my cat. Here's Indy. Isn't she a sweetie? Now, in the background, we've got a function running. It's going to look at this image, and it's going to send it through Cloud Functions based upon what? We put an image into cloud storage. Therefore, we have our URL where we can find that image. And when we find that image, we can point the Cloud ML Vision API at it. So Command plus. Command plus. So we have a log. And we have a few log entries going through saying, what do I think we found here, right? Well, where's that going? It's actually the ML API. Hola, gato. Hello, Eric. So if I put the same thing into the ML API, which you can see, cloud.google.com/vision, live demo, even better than mine. You can play around with it. There's a few different things that happen when we do feature analysis on an image, right? One of the first things we get is labels. We know kind of what these things are. We got properties about it, color schemes, things like that. We have web entities that are, these are kind of cool. This is a new thing that is basically trying to find the labels most corresponding to the highest number of similar images that we can find elsewhere in things that we've indexed. So in a way, if I could say, I'm pretty sure that this is cat, black mammal vertebrate, okay, that probably means cat. Or I could say that people call this a kitten, and I'm pretty sure that's a kitten. And if we go back to the chat app, sure enough, it told me that looks like a kitten. So I just picked the highest ranked value, pretty easy, right? So that's pretty neat. It turns out you can do a lot of things with this. Additionally, if I take something like, let's say, your favorite hipster Googler's LinkedIn profile picture, and you throw that in, here's me standing at the top of a building next to the Wrigley building in the Chicago River. area. So it actually found out where we are based on just the reflection and the pattern of the building in the background. I'm pretty sure that I didn't have any EXIF like GPS data left over in this image. It just sort of found that. Find faces. It looks like I'm happy. I was happy. I was at a wedding. It was a good day. So it's pretty sure that too. It can tell me things like how my head is turned and that sort of thing. I'm a facial expression person, hairstyle. I must not be labeling as hipsters today, but I would accept that criticism too. And then at the end, of course, we have a JSON blob that we can get back and do interesting things with. So again, that looks like a 2016 Tesla Model X to me. Looks pretty good, right? So what happens if we put up something that people don't really like? For instance, like zombies. We don't really like zombies. Now, why? This is PG-13 adult content. Okay, so my Firebase bot is angry. Bad. What happened here? Well, if I were to put this back into the ML API, zombies are pretty awesome. It's true. Fortunately, they offend my Firebase bot. And so what it's doing in the background here is it's actually gone and blurred the image out because it's kind of afraid of zombies. And so, we've done some sort of image moderation. What have we done here, right? We've took the safe search ranking of this image that we uploaded. We got a pretty high confidence score that that was inappropriate, right? And we decided to blur it out. So it's pretty cool, right? So this is the idea. You can take this function and you can throw data at it, and it's going in the background doing incredibly complex things in machine learning. I will say I'm now a machine learning expert because I took a one-day course at the Google office on the Monday of this week, and I retained probably about 10% of it. So I promised to go back and study. But TLDR, we built a really complex model. It's really hard to build that unless you have scads and scads of data. Google, being a search company, has a whole lot of data. So we have indexed these things. We've done feature detection on pretty much everything we indexed in the public internet. And you can use that to access all of the machine learning and recognition capabilities. So this is one example of this, right? So what else is happening in the background? So we've got a bucket. And in the bucket, we have got just some blobs, essentially. And in these blobs, we've got images. So these are just basically a place where you throw files at it. Pretty easy, right? Now, cloud storage is actually really powerful because this is replicated across multiple servers, multiple data centers, multiple regions, if you want it to be. So I have now an incredibly durable cat photo storage system with an incredibly sophisticated ML API that I wrote between the hours of about 9 and 3 in the morning last night after following 2 public code labs, and you can too. So real briefly, I would say doing this just to show in the Git history where this came from. I started from about here with a public code lab and did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 13 commits. So, this is not a lot of code. Now, they let me copy paste, so it was a little easier. But there wasn't really a lot that needed to be done here because the platform is really handling all of the heavy lifting underneath. So pretty cool. So Firebase you can use to build iOS apps, you can use to build Android apps, and you can use to back them with a lot of powerful things. So pretty cool. And hopefully none of you have been putting up ridiculously crazy. Oh my goodness, that was already blurred. That looks like a censorship to me too, thank goodness. Well, what else do I have for you today? I mean, if people like that just make me want to, murder people? No, we don't like that either, which will also be moderate. No, we don't like that either. So as you can see, we've got what? We have adult content filters. We've got violence filters. We have medical filters. We can do profanity filters on text. So pretty powerful stuff. It looks like a Dexter Morgan, at least for now. So you get the picture. You can all see this on your phones, I hope. So what have we done with our hipstery chat app with moderation? Hipsters must practice moderation. So we have a cloud storage event. We drop a message in, we log the message, and we name a cloud storage object after that message. That's it, right? So we split that up. We split it by the name of the bucket, which is the name of the app ID, basically an encoded base64 form. We've got the name of the actual message ID in another directory, and then we've got the image that you uploaded. We take that, pipe it through Cloud Functions, send it to the Cloud Vision API. We get a ranking. We get a rating. We get a pretty good idea of what it is. Now, it's not perfect, right? ML is not perfect. ML is not absolute, in fact. There's a non-deterministic nature to the way that MLs are trained. In fact, if you set up a very complex neural network and you want to see whether it worked or not, you have to run it from start to finish. And when you finish, if it didn't work, the advice we got was to randomly initialize the whole thing and start again. And it will converge. It's a complex function. It may not converge, but eventually, with enough trials, it will. Which is to say, you apply something like machine learning in your app. We've handled this for you, but it's still kind of an art and a science at the same time. So we are pretty darn sure this is a raccoon. It could be a red panda. It could be a trash panda if you're an Imager fan. But so plugging that into Firebase, you get the ability to do other things, other labs. The Hipster Chat was going to resize this for you. You can see the next demo of that if you want. We're doing all of these and basically by asynchronous promise callbacks to promises to the like an NJS backend that we're using to drive through Firebase. And so Cloud Functions has registered these things that I asked it to do. So if I look back inside of Friendly Chat, has got some functions. I look at the dashboard for the functions. I can see, oops, here we are. Add a welcome message to say hello, send a notification when someone posts a message, and do some ML stuff. That's it, right? I just registered these from the command line. My deployment task looks more or less like this. I would just say, well, this is to start up. Basically say Firebase deploy. And when I do that, I actually would say only functions because I'm actually deploying the functions. So I'm packaging up some code, if you can see that. Or sumo being, there we go. So it's going through all my code. It is doing the basically packaging, compiling into the format that we're using in the backend, which escapes me. If I have any syntax errors, if I have any undeclared functions, that sort of stuff, it'll happen here before I get up. Now I have a local web console that I can serve this from as well. So I have the ability to test this stuff in a more iterative fashion. Once you get into Cloud Functions, it's Cloud Functions. It's up there, not down here. So you do have to test that remotely. You can set up different staging environments and things like that if you want. So real briefly, behind the scenes, Firebase created a Google Cloud project for me, which contains all of the assets, all of the VMs, all of the storage, all of the functions, everything I could want to define for this. And I can create as many of those as I want, and I can keep them all separate. If I have a large organization or I have a development team, I can assign people to different functions and roles. So someone can write the ML functions, and someone else can manage the images, and someone else can delete the images if we moderate them out of existence. So you get a lot of flexibility there, but it all starts with a little bit of code and a little command line deploy. So what have we learned? Am I being spammed? I'm being spammed notifications. Excuse me for a moment. That's what I warned you about. All right, we're back. You've got mail. So we do a lot of stuff with Cloud Functions. We put it back into cloud storage. We've used Google Cloud. Google Cloud is cool. I have sales in my job title somewhere. So here's the pitch, right? You can unlock your data and your app dev processes. You can be a lot faster. You can be a lot stronger with Google, all of us together, right? If you use G Suite and our cool collaboration apps, we have a great slogan, all together now, right? So this is the idea of cloud computing, is we've got a lot of resources. They're yours to use. They're free to use for a trial membership for a little while. You can get $300 credit if you go to cloud.google.com and just sign up. You can play around. If you want to train a huge ML data set, that might not get you very far, but you can play. And if you want to go fast, if you want to go really fast, I would say for a mobile app dev, Firebase, not a bad way to go. If you want to get a little bit bigger, a little bit more back-end-ish and have access to more than just Cloud Functions and more than just Cloud Storage, App Engine is a great option. If you want to tune it up even more, you want to create your own containers, if you're into Docker and orchestration and that kind of stuff, or if your CI/CD pipelines are like things you dream about at night, you just have like gears turning in your head wondering what can I build here, Kubernetes might be a thing for you. If Kubernetes is a little bit too much work to manage, which some people don't love, Container Engine will do that for you. And Cloud Functions will allow you to throw data out there, get an answer back, hit all the cool APIs, minimal effort, right? So, in my opinion, better together, or how I learned Firebase in about 3 days and made an app that can more or less reliably classify your cat photos. So I know that's useful for some people. I happen to think it's very useful for the velocity of change. But if you want to try it for yourself, there are a few places that you can go to find out more. So first of all, I have stolen all of this content from publicly available presentations given at Google Cloud Next. You can find them on YouTube. There's a Cloud Next YouTube channel. If you want to see what we built today, what I showed off today, so there is a documentation on functions in Firebase, and there's documentation for both code labs as well as other options for mobile backend services. So hope you found that useful and interesting. So I'd like to do Q&A if you guys want to know anything, but first let me take a selfie. First ever dev talk at outside of a Google audience, so hello. Okay, so that's what I got. Any questions? Hello.
I have a question. That's a 1 billion free requests per day on average?
Something like that, yeah, across all instances. We've got a lot of scale there. Behind the scenes, we are throwing instances at a request rate that we're being asked for, right? So App Engine will scale up, and it'll scale down again. Billions of requests are not out of the question.
You have to like hit a certain level of like awesomeness, like billion requests a day to start paying.
You will pay for like hits and for data store accesses and things like that in App Engine, yeah. But it's interesting, there's stories about customers that had, I think it was like a boy band or something. There was a story in one of the next presentations that needed to scale their app up very quickly and then scale it down very quickly when sort of the stampede of social media traffic or whatever was finished. And they said that when they finished the app and then launched it and then sustained this, whatever promotional event they were doing, apparently their drink spill was higher than the App Engine charges. So I'm told. So we're told. You can obviously run up a bill on anything, but you only pay as you go. So everything that is an API or that is something like Cloud Functions, ML, those sorts of things, you pay per request. For Cloud Storage, you pay for how much you put in it, how long you keep it there, and how accessible you want it to be and where. For Compute Engine, you pay per VM minutes times CPUs and RAM, and it's very configurable. You can sort of customize that. But App Engine is definitely, I think, the way to get started for the cheapest way possible, because if you hit it a few times, you pay a few pennies. If you hit it a million times, you pay, well, probably not a million, but a little more than that. A little more than a few pennies.
So I wrote the app against the Firebase. So if I scale the app, then I need Google Cloud?
I'm not sure what the scaling characteristics of Firebase are, but the presumption is that it's going to do that for you, right? So I don't know. I know more about how App Engine scales in the back end, but yeah, you shouldn't have to tune Firebase instance size or anything like that, if that's what you're asking, yeah.
So if I talk to Firebase, I'm sure okay.
Yeah, you should. Yeah, you should be able to just use the platform and use the back end for what it is, and not have to worry about counting VMs. That's the point, right? Yeah. Anyone else? Hi.
So you had like that. You had like three compute engine functions.
Cloud Functions, yeah.
Cloud functions. What did you write those in?
What did I write those in? Yeah, you want to see the code? So this is all in. Oops. Oh. Editor isn't up. So there's only a couple things that we're doing here, really. So there's two main functions. There's a bunch of declarative stuff, and there's some imports. This is all Node.js libraries. So what I'm doing is I'm importing some functions. Can you see that all right? Importing some functions for Firebase. And I'm turning on a few things for the APIs that I want to use, for storage and vision in particular, right? We're using, this is, see, I even left a to-do developer in here. This is from the code lab, right? So this thing called exports is basically a way to register the function that I'm going to run with a particular promise that it's going to return a certain result. And when I go to Firebase command line tools to deploy that, it notices that I've declared them in this way. And so everything is just NJS in here. I'm not great at it, but I learned a little bit. So the part where we actually do the labeling is, so we do a couple things, right? So we find out that we got to change to an object. Someone uploaded an image, right? I was looking around for other event listeners, playing around with transaction synchronization. So the bug that I don't love in this, that I would love to fix for next time, is that it's actually trying to relabel and reclassify those images after it changes it, like it sees its own change. And it'll do that until it's satisfied that they're no longer offensive, which is probably a good thing if you blur things into oblivion if you need to, right? But that's why, for example, we said, oh, that looks like Dexter Morgan. Now it looks like blah, which is the case. So we go into Google Cloud Storage and we find a bucket. And that's just a storage location named after this project. It has a name and it has a regional location, as in US or Europe or Asia. And it has a storage class which talks about the availability that you want. It's very high durability storage no matter what. But for example, if I wanted the data to only live in the US, East, for example, versus all of the US, I could change that, and that would affect cost, and it would affect performance for people on the West Coast, for example. So then I go and get the file name, and all we're doing is make an API call, get some results out of it, find a bunch of web entities, and we go and see which of these has got the highest score, right? Once we have that, we say, looks like a something, whatever we found. Down here, we want to safety check the image, same idea. Detect safe search, this is the same functionality that you would see in the Vision API demo. If you click over to safety, safe search results, as well as when you do moderated safe search and public search results are doing something very similar. I'm not sure it's exact same thing under the hood, but you actually get the score out of it here as a plus or minus. So it says, is it a problem or not, right? And then we say probably non-zero value is something that we would like to moderate in some way. So we say bad user, and we say we don't like it. We go to blur it. The blurring is just going into the backend and saying, well, I'm going to go download the thing from the bucket. I'm going to run some image magic on it and run the blur effect. Now this is just a command line thing, right? So someone, somewhere, more like some process somewhere, has spun up time on a VM just for this function to run, and it goes away again. So you actually get access to a lot of other functions, not just within NJS API, but what VM where? I didn't see it. It's gone already, right? It's pretty cool. And then we send it back up, and we just say that we mark the thing as moderated. So registering functions pretty easy, and like I said, the only thing that confused me a little bit is I came from the Java world, and so doing all this async sort of multi-dispatch callback and promises stuff confused me a little bit, but works well enough. So still so many messages. Huh? What? Can you use better languages than JavaScript? I'm pretty sure you can. For Firebase, I think NJS has got a lot of examples out there. So that's a great question. I know for App Engine, you can use like 1 of 8 different things. For Firebase, I found NJS examples. Firebase languages, I actually don't know offhand. Which backend language should I use? Well, Python, JavaScript, Node. There you go. So Python maybe? There. I had to Google it, sorry. But yeah, there's.
I'm not sure this is the right question for you. What's the Google Cloud? What's the position right now? Because Amazon is Windows. They are both the two two big competitors right now, right?
Right.
IBM is behind.
Right.
So I think a couple of years ago, Apple switched from Amazon to Google. So
Right.
I'm not sure what's your position right now. Are you guys in the third place or is what place?
Oh, in terms of market share, you mean?
Yeah.
That I do not know offhand, and I will not speculate on financials. But I will tell you that, in my opinion, we have a very strong offering. I know that it is no secret that Amazon was a first mover there. And I think it's also no secret that Microsoft has got a lot of existing relationships with customers who got Windows on-premise. Obviously, we compete in things like collaboration and those things. And they're all good solutions, really. I will say, I think there's different reasons why you might use each depending on what your needs are. I think that we happen to excel in things like machine learning, and there are certainly differentiators for each of those.
Why do you hate relational databases?
Why do I hate relational databases? Well, in order to talk about that, I would have to talk about the time that I went to a very large customer at a previous employer and worked really, really hard to scale a relational database from a large vendor that I won't name, but who is very present everywhere. And yet we had these scalability issues, because the problem is this thing called the CAP theorem. You guys are familiar with it. It's an iron triangle, right? So like if you're in college, you say, pick friends, sleep, or studies, and you can only have two of those, right? One of these things, you have to give something up. In the case of database consistency, availability, and partition tolerance, you have a decision to make, because you can't have something that is going to write all the data exactly how you told it to write it all the time, and also be online all the time for all users, and also be resistant to some event that could disrupt communication between the nodes that you want to use to scale. And the last thing is kind of important, because we operate on the internet. We all have a networked environment that can go up and down, and things can crash, and subterranean or suboceanic cables get cut, and all kinds of weird stuff happens. So you actually have partition tolerance kind of as a requirement, and so you get to pick consistency or availability. So relational databases pick consistency definitively, right? They say, I want to make sure that I have an ACID-compliant transaction. When I write my data, it's atomic, it's transactional, right? All these things. And what that means is I have to pick a leader to do the writing of the data. When I say I want to write this record, I own it for a minute. I have to lock it. I have to do something like that. So what ends up happening is everyone else waits around, basically, right? So Firebase does not try to solve this problem entirely, right? I think Firebase and Cloud Data Store have a lot in common that way. Nominally a NoSQL database, nominally document-oriented. Transactional, yes, but not strongly consistent, eventually consistent, right? So the notion there is that I'm going to write my data. It will get to the disk, and it will be committed in the way that I wrote it, but it might not get there before the next request comes in. And so I need to design my app in a way that would tolerate that. And what I get out of it is the ability to scale horizontally without having to worry about complex locking semantics and things like that. Now, Cloud Spanner is an exception. Cloud Spanner does not quite break the CAP theorem. I'm not sure that's possible. We get really, really close. One of the ways we do that is by, in short, owning a lot of the backbone that we run our own networks on, and using things like atomic clocks to know exactly when a transaction took place and be able to reduce the complexity of trying to figure out who owned a particular right. So don't really hate relational databases per se. They have their limitations. If you need absolute consistency, the classic example, if you're a bank and you need to make sure that when I give you $100, that it comes out of my account and it actually gets to you rather than just disappearing into thin air. So that's kind of reason to want strong consistency. If I want to be able to do a transaction that, it's out there, right? It's actually not as bad as you think to have eventual consistency for the vast majority of cases where you don't need that sort of ironclad contract about write commits. Then you get more scalability as a trade-off. So that's about how that works. Brief foray into databases, since we have real-time database at the core of this thing. Anything else? Anyone interested in Firebase more or less? Interested in cloud platform more or less? Cool. I see thumbs up. I think that means good things. All right. So not much about me, but so I work out of Chicago. This is my first developer group meetup, hence the selfie. We've got a pretty big team there. I come to Cincinnati fairly often. I work with a couple sales reps, and I am the sales-ish geek. So I call my profession solution engineering. Google calls that customer engineering. So hence I put in my title on this first slide, customer solution engineer. If you think that you have a project that would benefit from Google Cloud, or you're just interested in trying it out, I'd be happy to talk more after. All right? All right, thank you.